Welcome back to the Deep Dive. We're here to cut through the noise of AWS announcements and give you the stuff you really need to know. And this past week, pretty intense, October 27th to the 31st saw, 52 updates?
Yeah, 52. It was quite a list to sift through.
But looking across it all, there's definitely a theme, right? It feels like infrastructural maturity, making hard things easier, almost invisible.
Absolutely. Things like connectivity, compliance, getting performance reliably, it's becoming more baked in.
So for our listeners, the tech folks tuning in, what are the key threads you pulled out from those 52 updates?
Okay, yeah. I'd say three main things jump out. First, a really strong push on security hardening, especially getting stuff off the public internet, even for management. Second, some really significant, quite specialized compute performance boosts, like databases, AI workloads.
Got it.
And third, developer tooling is getting smarter, particularly around deployment safety and observability.
Okay, that idea of hiding the complexity, making it invisible, that sounds like a good place to start. Let's dig into that first theme. Security, compliance, network isolation, the private cloud getting more private.
Right. The big story here is definitely AWS pushing to remove the need for public endpoints wherever possible, especially where the actual data path was already private. It's about that end-to-end isolation for regulated industries.
And the big headline there was Private Link GA for a couple of key services, starting with Route 53 Resolver.
Exactly. So Route 53 Resolver. Before you could resolve DNS privately, sure, but managing things like the DNS firewall, query logging, setting up Resolver on outposts, that control plane stuff, still needed a public endpoint. Now, with private link support, you can do all of that management entirely over the private AWS network. No public internet exposure for those admin actions. It's about getting that management footprint truly isolated.
Makes sense. And the other private link one, DynamoDB Accelerator DAX, you mentioned that fixed a kind of nagging compliance issue. What was the detail there?
Yeah, it really did. So with DAX, your cluster instances always lived inside your VPC. Data reads, writes, totally private, always have been.
Right.
But the control plane actions, like create cluster, delete cluster, changing settings, those management API calls still hit a public regional endpoint.
I see the gap.
Exactly. This update brings private link support to those management APIs for DAX. So now if you need total network isolation, both your data and your admin commands can stay inside the VPC. It's a subtle but really important fix for certain compliance scenarios.
Okay, that's clear. Beyond private link, there was also movement on IPv6, right? Dual stack support getting broader.
Correct. Amazon RDS now supports dual stack IPv4 and IPv6 for its publicly accessible databases, which sounds counterintuitive, but it helps organizations meet IPv6 mandates or simplify migrations where they still have some public interfaces but want internal IPv6 consistency. And similarly, Amazon Elasticache now also supports dual-stack service endpoints. For a lot of companies, especially federal or global ones, moving off IPv4 isn't optional, it's a requirement. This just makes that transition smoother.
And sticking with requirements, especially federal ones, there was a specific FIPS update.
Yes, for customers in specific U.S. regions in Virginia, Ohio, Oregon, mainly targeting federal workloads, Amazon Aurora DSQL now supports FIPS 140-3 compliant endpoints.
And FIPS 143, that's about the crypto modules being validated?
Precisely. It means the cryptographic modules used when your client connects to the database meet those very strict federal standards for encryption, whether it's a public or VPC endpoint connection.
Got it. Okay, wrapping up security, API controls seems to be getting much more fine-grained.
Yeah, definitely. Two good examples here. First, Amazon Cognito now supports OAuth 2.0 resource indicators. Think that you don't want an access token that gives access to all banking services, right?
Right, you want access to my account.
Exactly. Resource indicators let you scope that token down to a very specific resource, like one S3 object or, one bank account record. It massively reduces the impact if a token gets compromised.
Makes sense. And the other one was for mobile apps, location service.
Amazon Location Service added better API key restrictions. Developers can now lock down their keys, so they only work for specific Android apps based on package name or SHA-1 hash or specific iOS apps via their bundle ID.
So if someone swipes your API key,
they can't just plug it into some other random app or website. It makes those mobile interactions more secure. It feels like, AWS was really trying to let customers just delete the public internet from their architecture diagrams where needed.
Yeah, definitely raising the bar on that front. Okay, let's pivot. Theme 2, scaling compute capacity and performance. This is the raw power section, right? New instances, specialized tools.
Definitely some heavy hitters here. Starting with the high memory U7i instances. The big one, the U7i 8TB, is now live in Europe, specifically London.
And that's the one with 8 terabytes of memory.
8 terabytes of DDR5 memory, yeah.
Yeah.
And they're saying up to 135% more compute power than the older U1 generation.
Wow, 135%. That's not just an incremental bump. For things like SAP 8.0 or big Oracle databases, that could completely change how you run them in the cloud. Fewer instances, maybe?
Exactly. Consolidation potential is huge.
Yeah.
Also landing in London are the new R8i and R8i Flex instances. These use those custom Intel Xeon 6 processors.
Okay, the newest Gen Xeons.
Right. And AWS is claiming up to 15% better price performance and significantly 2.5 times the memory bandwidth compared to the R7i generation.
And they gave specific workload numbers.
They did. Up to 30% faster for PostgreSQL and up to 60% faster for NGINX web serving compared to R7i. Those are pretty compelling workload-specific gains.
Okay. And for government customers, I saw the storage-optimized instances hit GovCloud, the i7e. That's the one with the crazy NVMe density, isn't it?
That's the one. Yeah, both i7i and i7e are now available in AWS GovCloud regions. And the i7e is the real standout for storage, up to 120 terabytes of local NVMe, plus big compute and price performance improvements over the older i3 instances.
So for those big IO-hungry government systems needing compliance.
Yeah, databases, analytics. This is a major upgrade for speed and potentially fitting more on less hardware within that compliant environment.
Okay, instances aside, maybe the most interesting architectural tool announced this week, especially for AI and HPC folks, was that EC2 Capacity Reservation Topology API. Sounds complex. What problem does it solve?
It solves a potential nightmare for large-scale distributed jobs. Think massive AI training runs needing thousands of instances that must communicate with extremely low latency. Their physical placement, their network topology relative to each other is critical.
Right, you don't want them scattered across the data center.
Exactly. Before you'd reserve capacity and kind of hope for the best. Hope AWS placed them close together. You might over-provision just in case. This new topology API gives you a hierarchical view before you launch anything. It tells you the relative location and network proximity of potentially thousands of your capacity reservations.
Ah, so you can see which reservations are close to each other.
Precisely. So you can then intelligently schedule your workload, rank your nodes, and launch your instances onto the reservations that provide that tightly coupled, low-latency network fabric needed for optimal performance. It avoids wasting time and money on jobs that run slow because the instances ended up too far apart.
That is genuinely useful, a big visibility improvement. And speaking of making things easier, for more standard container workloads, ECS managed instances went GA everywhere.
Yeah, no. Generally available in all commercial AWS regions, this is a huge simplification push. It's a fully managed compute option for ECS. AWS handles the underlying EC2 instance provisioning, configuration, scaling, all that automatically.
Including patching? That's often a pain point.
Absolutely. It handles optimal task placement and, crucially, automates security patching of the host OS every 14 days. For teams running containers who hate dealing with AMI updates and patching cycles, this lifts a significant operational burden.
That operational simplicity is a perfect lead-in to Theme 3, developer productivity, observability, and automation, starting with deployment safety in ECS again.
Right. ECS is really building out its native deployment capabilities. It now supports built-in linear and canary strategies, alongside the existing blue-green.
Okay, explain linear and canary in this context.
So linear shifts traffic incrementally. You define the steps, like shift 10% of traffic every 5 minutes. Canary is more like a small test group, first route maybe 5% or 10% of traffic. To the new version, let it bake for a bit.
And watch the alarms.
Exactly. Both strategies integrate tightly with CloudWatch alarms for automatic rollbacks if something goes wrong during that phased rollout. It brings sophisticated, safe deployment patterns directly into ECS without needing complex external tooling.
Nice. And once things are deployed, especially microservices, understanding how they talk to each other is key. Service Connect got an update there.
Yeah, good one. ECS Service Connect now provides Envoy access logs. Since Service Connect uses AWS managed Envoy proxies to handle the service-to-service traffic.
Right, it sits in the middle.
We now get detailed logs from those proxies about each request, which service called which, the path, the status code, latency, all that good stuff. It's invaluable for debugging tricky cross-service issues, enabling better tracing, and just having an audit trail for compliance.
Okay. Now, things got a bit more abstract with the AI integration tools, something called the Model Context Protocol, or MCP. What's the story there?
Okay, yeah, MCP. Think of it as a standardized way for AI models or agents to securely talk to and understand external tools or resources. It's like a secure translation layer.
Got it.
So first, the MCP proxy for AWS went GA. This is a client-side thing. It lets MCP clients like Amazon Q or other compatible agents connect securely to MCG servers hosted remotely on AWS. And the key is it uses standard AWS SIG-v4 authentication.
So the AI agent can use its standard AWS credentials to talk to these resources.
Exactly. It allows those agents to securely interact with things like S3 buckets or databases without needing custom auth code for each interaction.
Okay. And then there was the server side, the AWS Serverless MCP Server.
Right. And this got some specialized tooling added, specifically for helping with AWS Lambda event source mappings, or ESMs.
ESMs can be tricky to configure sometimes.
They really can. So these new tools use AI to provide guidance. You tell it your goals like desired throughput or max latency for processing events from Kinesis or SQS, and it helps generate the optimized ESM configuration. It even includes a specific troubleshooter for Kafka sources, which, as anyone who's managed Kafka knows, can be complex. It's AI helping automate complex config.
Nice. Moving from AI helping with config to pure network automation, IPM got an update for prefix lists.
Yes, Amazon VPC IPM can now automate updating prefix lists using something called the Prefix List Resolver, or PLR.
Prefix lists. Those are the lists of IP ranges used in route tables and security groups, right? Keeping them up to date manually is painful.
Exactly. Super error prone, especially in dynamic environments. With PLR, you define rules. Like this prefix list should always contain all the IP ranges from VPC's tagged production in this IPAM pool. And ICAM just handles keeping it synchronized automatically. No more manual updates.
That sounds like a lifesaver for network admins. Okay, last one in this theme, monitoring. Prometheus added anomaly detection.
Yeah, Amazon Managed Service for Prometheus now has built-in anomaly detection using machine learning, specifically the random cut forest, or RCF, algorithm.
How does that differ from standard threshold alerts?
It's much smarter. Instead of you setting a fixed threshold like alert if CPU 80%, RCF continuously analyzes the metric's historical data to learn its normal behavior, including seasonality, trends, etc. Then, it generates a new time series representing an anomaly score. You can then set alerts on that score in Alert Manager, so you're alerting on significant deviations from normal behavior rather than arbitrary fixed values. It's much better at catching unexpected spikes or dips.
That does sound more intelligent. Okay, let's shift to our final theme. Theme 4, data processing and AI foundation models. Lots happening in multimodal and just raw data speed here.
Definitely. Starting with the AI side, Amazon Nova multimodal embeddings hit general availability. This is pretty cool. It's a single embedding model that understands and can relate text, documents, images, video, and audio.
So you can search across different types of media using one model, like find images based on a text description or vice versa?
Exactly. Or search video content using text. Or query a document that has both text and charts. It enables true cross-modal retrieval. It handles inputs up to 8K tokens and video segments up to 30 seconds.
Okay. And TwelveLabs also had an update for their video model.
Yeah, their Marengo Embed 3.0 model got some boosts. It can now process much longer videos up to 4 hours or 6 GB files, which is double what it could do before. Great for analyzing things like full sports games. They also expanded language support to 36 languages.
Impressive. Now, maybe one of the most critical AI updates for enterprise use, reducing hallucinations. Web rounding for Nova Premier.
Yes, this is a big deal for reliability. Web grounding is now GA, available via the Bedrock Tool Use API. It lets Nova Premier models perform Retrieval Augmented Generation RAG using up-to-date real-time information fetched from the public web.
So the model doesn't just rely on its training data.
Right. It can pull in current info. And crucially, it provides citations for the information it uses. So when it answers a question using this grounded data, it tells you where it got the info.
That dramatically increases trust, I'd imagine.
Hugely.
Yeah.
It significantly reduces the risk of factual errors or hallucinations, making these models much safer and more trustworthy for generating content, especially for customer-facing applications.
Makes total sense. Okay, rounding out theme 4, some pure performance wins for data services. DocumentDB first.
Yep. Amazon DocumentDB, the MongoDB-compatible one-release planner version 2.0. This is basically a rewrite of their query planner engine.
And the result?
Up to 10x performance improvement for find and update operations that use indexes, especially for queries involving tricky operators like negation, not non-ioning, or complex nested conditions.
Wow, 10x is significant. That's not just a tweak.
No, it's a core engine improvement. It means queries that might have been too slow for real-time use before could now be viable. It comes from better cost estimation and smarter index scanning logic for those harder query patterns.
Okay. And finally, Kinesis data streams got a size bump.
It did. The maximum record size supported is now 10 MB, up from the old 1 MB limit.
10 times bigger. Why does that matter?
It simplifies pipelines. Sometimes you get these occasional really large data blobs, maybe a big sensor reading dump in IoT, or a large change data capture event, or outputs from generative AI. Before, you might have needed separate handling or complex logic to split them. Now, Kinesis can just handle those larger records directly, simplifying the ingestion path.
Got it. So looking back at the whole week, it really does feel like that theme of maturity holds up. Secure networking getting hidden, performance boosts baked into instances and databases.
Yeah, the complexity is still there under the hood, but AWS is providing much better tools and defaults to manage it. Whether it's private link, automated IPM, AI helping with config like those MCP tools, or just faster instances out of the box.
The tools are getting smarter and more granular.
Exactly.
Which actually leads perfectly into our final thought for you, the listener, to chew on. We saw this week that Amazon EKS split cost allocation data now lets you import up to 50 Kubernetes custom labels per pod as cost allocation tags.
Right. That's incredibly granular visibility into where your money's going on shared clusters, down to the individual pod level based on labels you define.
So the question we want to leave you with is this. How does that level of detailed pod-level cost tracking, when you combine it with these new, safer deployment strategies like ECS Linear and Canary, fundamentally change how you think about structuring applications and justifying cloud spend?
Does cost allocation start being just a monthly report you look at after the fact and become something you have to design for architecturally right from the CI/CD pipeline? Does knowing the exact cost impact of deploying a new version of a microservice change how you approach it?
Something to think about as you architect those shared compute platforms. It definitely blurs the line between FinOps and core engineering decisions.
Definitely something to mull over.